The question 2 also focuses on some of the inferential statistics we've already discussed. So the first question under question 2 is there a linear relationship between study hours per week and their corresponding test scores? And on average, does the test scores differ differ across differ from the instructor's target of 60? And is there a significant difference between the test scores of female and male students in the three instructional groups? Okay, so for the first part, is there a linear relationship? In checking relationships, there are three options we can consider. We have the Pearson correlation, the Spearman correlation, and the Kendall-Tau correlation. Okay, for all these three, there are assumptions we base on to select the appropriate one for this type of analysis. Okay, so in order to determine which one to use, it will depend solely on the two variables you are looking at. So if one of the variables is ordinal in nature, we can consider the Kendall or the Spearman-Rao correlation. For the Spearman, it looks at both of the variables being ordinal. Okay, so if both variables are ordinal in nature, then I can use the Spearman correlation. But then if I want to check a linear relationship, okay, a linear relationship would mean that if I'm to draw um a line, or I'm to plot the values for the test scores and the study hours, and I draw a straight line through the points, I'm going to get a straight line. I'm not going to get a curved line. Okay, so that's the meaning of the linear. So if I want to assume that there is a linear relationship between these two variables, the only type of correlation I can use is the Pearson correlation. Okay, and again, we looked at the descriptive statistics for the study hours per week and the test scores, and per the results we had, they were both fairly normally distributed, and we can only use the Pearson correlation when the variables we are looking at are normally distributed. Okay, so it means for the first part of this question, we can only use the Pearson's correlation. Okay, so how do we perform the Pearson correlation in SPSS? So here in SPSS, we go to analyze, and then all the correlations can be found under this option, which is correlate. Then we choose bivariate. Okay, so our variables will go into this variables box. So that will be the test scores, the test score, and the study hours per week. And then here I'm to select the specific correlation coefficients to use. And the test of significance is also dependent on the hypothesis you are going to draw. Okay, so depending on the hypothesis, you select the type of the test you want, which is the one-tailed or the two-tailed. And the correlation coefficient, we've already established that we have to choose the Pearson. Okay, so after choosing all these, click on OK. Then we interpret these results. Okay, so the table we are going to get from this analysis will be a 2x2 table. Okay, so we can see study hours here and the study hours here, then the test score here, test score here. Okay, so if I want to know the correlation coefficient between the test score and the study hours per week, that would be this value. So the test score, study hours, so this value. Okay, and the p-value is directly beneath uh, the correlation coefficient. Okay, and we already know how to interpret p-values. So based on the values you have here, you interpret the values you are getting in the table. We will look at the interpretation of the tables in a different video. Okay, so for the second question, on average, does the test score differ from the instructor's target of 30? So here we are trying to find out whether the test scores on average is different from the target of 60. And whenever we want to check differences, there are some options we can also have. Okay, for the parametric aspect, we can look at the t-test and the ANOVA. And for the non-parametric aspect, we can also look at the Mann-Whitney U-test and the Kruskal-Wallis test. Okay. Already, we've already we've already generated the statistics for test scores. So we know that the test score here is normally distributed. So we can assume that the test score here is normally distributed for this analysis. So if we are making that assumption, then we can choose any of the parametric options. Okay. So because we are comparing a sample to a value or a parameter, we can only use one of the four options I mentioned. Okay, so we can only use the one sample t-test out of the t the two sample t-test, the paired sample, the ANOVA, and the one sample t-test. Okay, so the one sample t-test always looks at comparing a sample to a particular parameter. Here, our parameter is the target of 60. Okay, so in order to perform that, come back to SPSS, go to analyze. Because you are looking at averages, we go to compare means, then we choose one sample t-test. So the test variable box will take the variable or the sample I am comparing to the parameter. Here we am comparing the test score to a parameter of 60. So that 60 comes into the test value box. Okay, so 60, then I click on OK. This analysis is also going to give me three tables. The first table being a descriptive summary of the variable I am using, which is test score. And the second table is the one sample t-test results itself. Okay, so here I would find the test statistic, the degrees of freedom, the confidence interval for the difference, not the values, not the test score variable itself, but the difference. Okay, and then the p-value is also reported here. Again, we will also look at how to interpret these results in a different video. Okay, now for the second part, is there a significant difference between the test scores of male and female students? Again, we are also looking at difference, and because we've already established that test score is normally distributed, we will choose amongst one of the four parametric options. Okay, here I won't choose a one sample t-test because I'm comparing the samples of females and males. So here I'm comparing a sample to another sample. Okay, so in that instance, I cannot use the one sample t-test like we did for the previous one. Here I would rather use the independent samples t-test, which is this option. Okay, so I'll select the variable I'm trying to test for. And then the grouping variable will take the variable containing the two samples. Okay, here that would be the gender, right? And after selecting the gender, I would have to define which group should be my sample one and which group should be my sample two. Okay, I have not coded this data yet, so it means I have to enter in the male and the female as it has been written in the data set. Okay, if you've coded the variable gender, you could replace that with 1 and 2. Okay, so after fixing in the values for the group 1 and group 2, click on continue and then okay. Then you have this table. The first one is still the descriptive statistics for the variables. Okay, and then the second table is the independent samples table itself. The first part of this table is a test for one of the assumptions of the independent samples t-test. So whenever we perform an independent samples t-test, we assume that the variances for the two groups are the same. Okay, so in this instance, we are assuming that the variance for males with respect to test score is the same as the variance of females. Okay, and then this test is to verify whether that assumption is valid or not. Okay, So based on this significance value, I can conclude whether the variances are the same or not. And then the second part here also looks at the results for the independent samples t-test itself. So you have the test statistic here, the degrees of freedom, the significance value, which is the p-value, the difference, the standard error for the difference, and the confidence interval for the difference. Okay. Now, the last part, we are looking at whether the test score differs across the three instructional groups. So here you might be tempted to use the independent samples t-test, but remember the independent samples t-test can only pick two groups. If we have more than two groups, we can only use ANOVA. Okay, so instead of choosing the independent samples t-test here, I'd rather choose the one-way ANOVA, and then my dependent list will take my test variable. Okay, my test variable here is the test score. Okay, and as a trick, the dependent list is always the variable with the numeric values. Okay, and the factor here is the variable that contains the groupings. Okay, I have not seen the group or the instructional groups here because I have not coded my instructional group yet. Okay, so if I had coded it, I would see that option here for me to choose and fix it under the factor. So it means we would have to go back and recode the group before we can continue. Okay, so now I've been able to code my instructional group and I can now clearly see it here, right? So I can push that variable into the factor list and then click on OK. Okay, then I have my results for my ANOVA. Okay, so again, we will know how, or we will learn how to interpret this table. If this table is significant, then we would have to perform a post hoc analysis. And to perform that, we still go back to the same dialog box, and then under the post hoc here, we will select either the LSD or the Tukey here. You can decide to select both, but both will give you the same, on average, they'll both give you the same results, right? Okay, so you can select one of them. I am selecting LSD. I'll click on continue and then OK. And then you will get a table for the pairwise comparisons. Okay, again, we will look at how to interpret this table in a different video as well. So that wraps up the solution for question 2. Okay, the next video will look at the interpretation for the tables we generated in question 1 and question 2. Okay.